Hi everyone. Today I'm going to talk about the critical radius of thermal insulation, which is one of the most important topics of heat transfer. Let's see the definition. Critical radius of insulation is defined as the outer radius that provides the maximum rate of heat transfer or heat loss. Let's see this with an example. Consider a cylindrical pipe. Let's say small r1 is the radius of the pipe and small t is the cylindrical thickness. T1 is the cylindrical surface temperature. T infinity is the ambient temperature or the room temperature. H is the convective heat transfer coefficient. When we calculate the total heat lost from the cylindrical surface to the surrounding, we get this equation, that is Q is equal to H 2 pi R1 L, where L is the cylindrical length, T1 minus T infinity. And this is by the Newton's law of cooling for convection. When you observe this term, there's some amount of heat lost. To minimize this heat loss, provide the cylinder with insulation, and that is our next step. Now in this case, the same cylinder is provided with an insulating material which has a low thermal conductivity denoted by capital K. Now when we pass the heat, here the heat transfer takes place by convection and then through this R2 by R1 by conduction and then again convection. When we calculate the total heat transfer from this end to the surrounding, we get this equation, that is T1 minus T infinity upon ln R2 by R1 2 pi Lk plus 1 upon H 2 pi R2 L. Here the two terms are to be considered, that is R conductive and R convective, where this term is the R conductive, that is the conductive resistance, and this term is the convective resistance. And when we vary the R2, we observe that this term increases and this term decreases as is in the denominator. So, according to the definition of critical radius, it suggests that critical radius is the radius at which maximum heat transfer takes place. So, in order to obtain the value of critical radius, we are differentiating the equation of heat transfer in order to find the value of critical radius. Now, by differentiating this equation with respect to r, we get this dq by dr and we equate it to 0 and thereby get the value of r2, that is the critical radius, that is k by h, where k is the thermal conductivity, h is the convective heat transfer coefficient. And finally, r critical is nothing but r2, that is k by h, which is the required radius at which maximum heat transfer or heat loss occurs. So when we plot the graph of Q versus R, now Qmax occurs at critical radius, and that is according to the definition of critical radius. But our aim was to minimize the heat losses, but by increasing the thickness of insulation, we are not decreasing the insulation or the losses, but rather increasing the heat losses. So why are we considering the critical radius definition or analyzing this? Because the critical radius not only gives us the maximum value of heat transfer or heat loss, but also the standard value or the reference value below which the heat transfer rate goes on decreasing, and provides us with a particular thickness at which minimum heat loss can be obtained. We cannot completely eliminate the heat losses, but can definitely minimize the heat losses, and that is perfectly done by critical radius by providing us a reference. And that is all about the critical radius of thermal insulation. Thank you all.